This video is the solutions of homework of lesson 8. Question number 2 asks us for the best estimate of the refractive index of a medium in which light travels at a speed of 2.87 times 10 to the power of 8 meters per second. Now, index of refraction will obviously not be 0.9 or 1. It has to be larger than 1. So we're left with C and D. Well, the speed of light is 2.7, which can't be 2.7 times 3, which is the speed in air. So estimation gives us C as the answer. Question number 6 gives us light traveling from air into glass, and we're given two angles and ask for the refractive index of glass. We know that we must always use the angles made with the normals, so that would be 60 degrees and that would be 10 degrees. And the refractive index of glass would be the sine of angle in air divided by the sine of angle in glass, which gives us C. Question number 10 asks, according to this diagram, the sound can be heard from X on Y due to diffraction. This is the concept that we studied in lesson 8. Question number 14 gives two waves that meet at a point, gives us the path difference lambda over 4, and asking for the phase difference between the waves. We're basically looking for the angle equivalent in radians of lambda over 4, which is quarter of a wavelength. So quarter of 2 pi would be pi over 2. Question number 19 gives us monochromatic light traveling from air into water. This is a case where light will obviously slow down, which means the wavelength will decrease when the speed decreases. So the answer is clearly D. Question number 20 gives us a diagram where plane wavefronts are incident on a boundary between media labeled 1 and 2 in the diagram. This is medium 1 and that is medium 2. And the question asks the ratio of the refractive index of medium 2 to the medium of 1. Now, from the diagram, we can't relate to the speeds, we can't relate to the angles as we don't know what they are, but we can measure the wavelengths. So index of refraction and wavelength is inversely proportional. So I'm going to complete it like this to find our answer. Wavelength in medium 1 would be measurement of that distance. Wavelength in medium 2 would be a measurement of that distance. When you make relevant measurements, among the 4 options, you find that this is 2/3, so answer is B, 0.67. Question 21 is another refraction question. We are given 4 angles labeled. Since we know we must always use the angle between rays and normals, we are only interested in that angle and that angle, which is theta 1 and theta 4. So which one of the following is the refractive index of glass? The answer is D, because this is air and this is glass. So refractive index would be the sine of angle air divided by the sine of angle in glass, which is this question gives us a spring attached to a mass. The right side of the page is given as the positive direction. It's frictionless surface, and one end of the spring is fixed. The equilibrium position is given as B, and the oscillation is taking place between points A and C. Part A asks us to define simple harmonic motion. We know the definition of simple harmonic motion is based on the relationship between acceleration and displacement. So first we must say acceleration is proportional to displacement, and acceleration is always in the negative direction of the displacement. The second part of this question gives us an axis to sketch a graph of acceleration versus displacement. We know, based on the definition above, we know this graph must be a linear proportionality, so a straight line passing through the origin. And we know it must have negative gradient because acceleration and displacement are always in opposite directions, which gives us this. On the graph, label the points that correspond to the positions of A, B, and C. This would be A, equilibrium position B, and that would be C. When you sketch this graph, make sure that length and that length are approximately equal. Same on the vertical. This is not a continuous graph. This graph actually ends here and it ends here. You cannot put arrows because this is an oscillation. The maximum displacement it can ever get is point C and point A here. Part C of this question gives us a diagram where wave Y and wave X meet in the same medium. The position of the waves is given on the horizontal and the particle displacement is given on the vertical. We are given that wave X is traveling from left to right. It has a wavelength of 2 meters, and wave Y traveling from right to left has a wavelength of 4 meters. This is also apparent in the diagram. Both waves move along the spring at a speed of 10 meters per second. So state the principle of superposition as applied to waves. 2-mark question. There are 2 parts to this answer. When 2 or more waves meet in a medium, the resultant displacement is the vector sum of individual displacements. The next part is asking, by drawing on the diagram or otherwise, calculate the position. We're looking for a position at which the resultant wave will have a maximum displacement 0.2 seconds later. So we need to shift these waves on the diagram for 0.2 seconds after their current positions, and we're looking for the point where the resultant will have a maximum. So what I'm going to do is to take the maximum of wave X and take the maximum of wave Y, which are at 3 meters and at 7 meters respectively. Since they move at a speed of 10 meters per second, after 0.2 seconds, they will both have traveled 2 meters. Wave X is traveling to the right 2 meters, and wave Y is traveling to the left 2 meters, which means the maximum of wave X will be at x equals 5, and the maximum of wave Y will also be at x equals 5, which means that will be our answer. So as an explanation to show your work, you can write this in words, or as a drawing on the diagram, you can actually show your work by labeling on the diagram.